Okay, you guys, this is lesson 1-1. This is actually the pre-lesson. Um, so I'm going to take these little bites, one little bite at a time. And of course, using this video, you can rewind it and listen to it again if anything throws you for a loop. I'm Mr. Kleefish, and let's begin this journey. So we're going to start with this thing called interval notation. And what this is it's a transition from what you're used to, which is inequalities, to a new way of saying the same thing, interval notation. Now, why? Well, pre-calculus is where you're headed, and higher level math is going to use this language, and that's all math is. It's a new language. Now, some of you are like, well, why did they create a new language? Well, think of it this way. Why is there English, Chinese, Espanol? It's a language. And to continue in this journey, you need to learn that new language. That's what calculus really is. So with that being said, let's start. So I'm going to start right here, what I'm used to. Now, what you guys are used to is plotting points. Now notice, -2, that's my x value. 3, that's my y value. You guys have been doing this since you were a little, whatever, 4th grade, 3rd grade. So that means move left 2, move up 3. And that is a point, a coordinate point. All right, why am I starting with this? You'll see. This is what you're used to. So now you've got this idea, interval notation, where you look at, we're just going to call this the x-axis. So think of these as your x values. And notice there's an open circle for -1, a closed circle for 3. Now, in what you're used to, inequalities, you would say, okay, x for this one can be strictly greater than -1. It does not include -1, that's why it's strictly greater than, but it's also less than or equal to 3. Notice, less than or equal to, filled in dot, strictly greater than, open circle, because it doesn't include it. Hopefully that jogged your memory a little bit. Let's go down to this one. Notice, filled in circle, filled in circle. What are you guys used to? You're used to saying x is greater than or equal to 1 and less than or equal to 3. Same thing here. Filled in circle, open circle. X, because that's what we're talking about, is greater than or equal to -1, but it's also just less than 3. I almost put a little or equals. That wouldn't have been correct. This one, open circle, open circle. What does that mean? X is greater than -1, but it's also strictly less than 3. And this is what we used to use to describe this sort of situation when we're talking about the x values. Now we're going to just use some new symbols. So as long as you have this in mind, these new symbols shouldn't be that big of a stretch. You just have to learn the new stuff. So what you're going to do, similar to this, is parentheses is the same thing as open circle. And then there's going to be a new thing called a bracket, which is for this. So, for example, this one right here, I would say parentheses, -1, all the way up to 3, bracket. Now the bracket, remember, means it includes 3, just like this meant it includes 3. The parentheses means it does not include -1. So there's the difference. This one, it includes -1, it includes 3, and everything in between. So I'm going to use a bracket, -1, comma, 3, bracket. A little bit different, but not a big deal. This one, bracket, -1, comma, all the way up to 3, parentheses or bracket. Correct, parentheses. Now this one is parentheses, parentheses, comma, which looks a lot like this coordinate point, but it's not. It's different. It's talking about x values only, -1, 3. And I'm going to hit pause for just a second. Okay, now we're moving on. 2 terms. These are biggies, okay? Biggies. You're going to hang on to these 2 terms. Domain, range. Domain, range. What is domain? Domain is your code word for for your x values. What is range? That's a code for your y values. Now, notice alphabetically, D comes before R, X comes before Y. So there's a little memory tool for down the road. When you see the word domain range, you get a little confused. Domain is X, range is Y. Now we need to be careful. There's also, we just got done learning about interval notation, which we'll talk about in a minute. But we also have this thing called set notation, and this pops up if this is your situation. Notice we just have 3 coordinate points. And here we've got 2 coordinate points, but then we've got an infinite number of coordinate points in between them. So how do you handle these? Well, to talk about our domain in set notation for this, I'm going to talk about my x's, because that's what x's is. And so that's my x value, my y value, my x value, my y value, my x value, my y value. So there's only 3 of them. 1, 2, 3. So set notation, I call it teacher thingies, because teachers are good at it. You start with the lowest one, and then you move up, typically, and then 2. And then there you go. There's your 3 pieces of your domain. What about your range? Well, your range, remember, it's your y values. So we have this one, and this one. Again, you start with your lowest value, regardless of whether it's x's or y's. So we're going to start with our lowest y, which is -1. Here comes the set notation, -1. The next biggest one is 1, so we're going up, and then to 2. And there's your answer. There's your domain, set notation, range, set notation, because we have points. Now here's where you're going to have to use your noggin a little bit. Remember I said there's an infinite number of points? Are we really going to spend the rest of our lives listing every single one, including the decimals, like 2.77459? I mean, that's kind of silly. Keep this in mind. Interval notation. Domain, it's my x value. So domain in this situation is really asking you, how far left does this go? Well, it goes all the way to -3. Remember, it's a closed-in circle. So I'm going to use a bracket and go -3. Remember what domain is. It's my x value. And x-axis looks like this. It's left and right. So how far left does this line go? -3. That's why I put it there. Now how far right does it go? Notice I'm not talking about up and down. I'm talking strictly left and right. And this one goes 3 units to the right. And it also gets there, because that's filled in dot, so we use a bracket. Now let's talk about the range. Well, the range is your y values. Remember, your y-axis is your up and down axis. So you start with thinking, okay, if that's my range, which is my y value, question is, how low does it go? Well, it gets down to -2. So I'm going to put that in a bracket because of the filled-in circle. Now how high does it go? It gets up to 3. And there's a quick explanation of the difference between domain and range, and the difference between set notation and interval notation. So if you're talking about graphs, which we're going to be doing 99% of the time, you're going to use interval notation. Hopefully that makes sense. Okay, moving forward. 2 more terms. X-intercepts. Think about football, make an interception, your body has to cross the path of the football. Same thing with graphs. So you've got a graph here, and you've got x-intercepts. Where does it cross? The x-axis. And so you go along the x-axis, and you're like, hey, right there. So this right here would be considered your x-intercept. Now the other term is y-intercept. So this is my y-axis. So you travel up and down the y-axis. Where does the graph cross it? Right there. So this one right here would be considered my y-intercept. Now that's pretty simple, but I'm going to throw a little additional thought here. Notice my y-intercept, x, is what equals 0. Now this is going to be very helpful coming up, or else I wouldn't waste your time with that little thought. Notice this is my x-intercept, but notice my y equals 0. So how do you find your x-intercept? You let y equal 0. That is if you're dealing with an equation. Just tuck that away. How do you find your y-intercept? You let x equal 0 and you plug that into your equation. We'll talk more about that. I just want to plant that seed right now. Let's move on to this one. I got two parabolas. These are called quadratics. What is this one? Well, let's find the x-intercept. I'm talking about this purple parabola right here. Notice it doesn't even cross the x-axis, so this graph does not have an x-intercept. Y-intercept, it crosses the y-axis right here. Notice 0, 10. Again, my x is 0 to find my y-intercept. Now let's talk about this red one a second. Where are my x-intercepts? Well, they're right here and right here. 12, 0. Remember, y is 0. 6, 0. Y is 0 to find my x-intercepts. Now, how about my y-intercept? Well, it's right there. Here's my y-intercept. But notice, x is 0. Okay. All right, almost done with this first little pre-lesson. And the next term is finding, because they're going to ask you, find the 0 of a function. First of all, the word function, you could also think of that as an equation. Now, we'll talk more about functions later, but for now, I just want you to think of it as an equation. We have an equation here, we have an equation here. Another word for them is function. Now, the 0 of a function is the same thing as the x-intercept. Now, if you were listening to my lesson 2 seconds ago, I said, wait a minute, there's a trick. If there's an x-intercept, ironically, you let y equal to 0. And then you solve. Oh, I screwed up. Hold on. I didn't screw up. So start thinking backwards. Shame on me on the first lesson. Yeah, you let y equal 0, and then you solve for x. Now, forget the graph for a second. Let's just follow these rules. Let y equal 0. Just say, okay, 0 equals 2x plus 6. Subtract 6, and that equals, I get negative 6 equals 2x. I'm going to divide by 2, sorry about the math, x equals negative 3. So my 0 for this equation would actually be 1, 2, 3, to the left, 0. Now, if I was to actually graph this, which you're going to be doing some graphing, this is a quick reminder. Here's my y-intercept, 1, 2, 3, 4, 5, 6. And then my slope is right there. So I go up 2, 1, 2, right 1, right there. Notice the line would go right through there. So you don't need the graph. I just wanted to show you what it is you're finding. Okay, what is this? Well, again, we're finding the zeros of a function. Equation. When you see this, find the 0, it means find the x-intercept. Keep that in mind, which means let y equal 0. So we say, okay, we're gonna take this guy, we're gonna go 0 equals x squared minus 6, add 6 to both sides. And I don't know if you remember this, but to solve this, the way I teach it is bada boom, bada bing, do the right thing. Now, I don't want to overwhelm you with this, but if I was to graph this, y equals x squared looks like this. The minus 6 takes it down 6 units. 1, 2, 3, 4, 5, 6. So it actually looked something like this and like this. Now, what is the square root of 6? Well, it's a little more than 2. So that means I'd have to go left a little more than 2, right a little bit more than 2. Bottom line, my zeros for this parabola here would be right here and right here. So one of them would be the square root of 6, 0, and the other one would be negative